Hi everyone. So we've got two case studies this year, and so the first is from the banking space, which we obviously do a lot of work in. The reason I wanted to talk about this one in particular is for two reasons. One is it's a pretty meaty process with a lot of complexity. Hopefully we'll give people some ideas on some of the things that we can do. The other though is I sort of want to paint a picture of the journey we went on from sort of first discovering the problem to doing a POC to going live, and some of the various obstacles along the way, and obstacles that we tend to see in a lot of big companies, which may resonate with some people sort of as I journey through these slides. So it's essentially a reconciliation, and in this case, being a big bank, it's all about complexity. They have a lot of assets that they need to look after, and obviously being one of the big four banks, they have our money. So they're responsible for us, for ordinary Australians, and they need to be careful with that, and they're accountable to the regulators. So in this case in particular, it's APRA that we're sort of talking about. Part of what they need to do is they need to keep tabs on their capital, or their capital adequacy, more accurately, and they need to provide information to APRA on a fairly regular basis, monthly, I believe, just showing that they have enough capital to cover all of the various assets that the bank holds. And in order to do that, they need to calculate the risk on all those assets. So they built a risk engine internally, which in turn is pulling data from the data warehouse. So basically all the transactions across the bank, so bonds, derivatives, etc., are all flowing through. And that data in turn is coming from different source systems from all over the place, so 50 plus in total. And part of the challenge is in that piece that connects the source systems to the data warehouse, where you have all these data pipelines going in every single direction. And really, this is about being sure that the data is traveling in a perfect way from those source systems to the data warehouse. Because if that part's not right, or if there's something broken there, you're potentially calculating the wrong numbers. So they need to reconcile the source systems with the data warehouse. And basically it's about checking around 500,000 transactions. You have 50 plus files that are being checked. So you take data dumps from all the source systems, you take a dump from your data warehouse, and really what you're looking for are mismatches in data. So that could be a transaction that's on one side but not the other. It could be a transaction that is on both sides, but where the value is slightly different on each side. So originally it was a manual process that they created here in Australia. Like a lot of these types of processes in banks, it was packaged up and offshored probably about 4 or 5 years ago. And some of the main challenges that they had was obviously time consuming, and they were struggling to meet deadlines, in particular in terms of getting the work done and then handing it back to some of the onshore experts who needed to do the final review. The other challenge was that there was so much data that they couldn't do the checks on desktop tools, so they couldn't do it in Excel. And I believe they were passing the data through an Access database, aggregating it up, and then doing the checks at a higher level. But they really wanted to do it at the transactional level. And then the third was that, and this is quite common, the knowledge slowly dissipated over time, where as turnover occurred offshore and new people came in, each person that would come in would know slightly less than the person before them. So those are the three main things that they really wanted to address. And actually, when we first met them, they didn't know that we're an automation tool. They thought that we were primarily a workflow tool, and they just wanted a way to make sure that people had carried out every single check in the reconciliation in a particular way. And then after we showed them Solvexia, they obviously came to the conclusion of, well, why don't we just automate the checks that they're doing, and then we can be really sure that they're being done right. Like a lot of these projects, it started with a POC. And I think that was really well thought out and selected. So it was a global process, but it was broken up by different regions. So they started by picking a single region, but they made sure they picked a region that was meaningful and representative of all the other regions. So in order to get the most value from the POC, they picked a region where the data was reasonably clean and understood. So we've seen people in the past, and I'll talk about this in one of the other presentations, where the last thing you want to do is pick a process where you're already fighting things like messy data or knowledge not being available in terms of subject matter expertise, because it just makes the whole thing harder. So they were really clever in picking a process where that certainty was there. And as I said, it was something that they could then package up and reuse if they went live, and when they ultimately did go live. So the POC that we built is fairly straightforward. It takes the source system data, takes data from the data warehouse, it does some validation and cleansing, and I'll talk about these as I go along. It cleanses some of the data, does some mapping, does the reconciliation, then produces some results. In terms of consolidating data, really what we're talking about here is being able to take lots of different data sets, say bonds data, futures data, etc., and stack it all on top of each other and make sure it's all aligned. And there's another presentation that I'll talk more about this business problem, because we see this happening a lot in a lot of industries, so needing to take just a whole heap of data and stack it together nice and neatly. In terms of the cleansing of identifiers, in order to match the transactions, you need to make sure that the transactions actually resembled one another. So that could be anything from removing weird characters from one side or another to, in some cases, the IDs being completely different. So needing to find other fields that you wanted to match on to do the reconciliation. And then in terms of mapping to the reporting structure, it's about being able to take that data and saying, okay, well, all these transactions are bonds, these transactions are futures, and then being able to have a structure in place where if there's a new product in the future, you can easily have the system grow and adapt and be able to take those records and reconcile them as well. And also, in order to do the check, we created this rules table that would allow someone to say, okay, so for everything that's mapped to bonds, these are the fields that we want to group by. And then these are the fields that we want to compare. And that was really, really important, because then again, in the future, when a new product came along, this is just an Excel table. One of the business users can go in potentially and just add those records in, rerun the process, and then do the reconciliation with the new data. So it reduces some of the dependency on us or whoever's looking after the process. And then in terms of the reconciliation, so it takes that data, it does all the usual sort of things you'd expect. It's faster, it's consistent, it makes sure that every step is done, and then it produces some sort of key results around, well, where are the variances, by which instrument. It produces two main types of variances, the mismatching records, so ones where they're on both sides, but the values are different, and what we call delinquent, so on one side but not the other. And then you can drill into those results and you can see which transactions have the issues and so on. So the POC itself was pretty successful. One of the key things also that's worth pointing out is at the time they didn't actually have permission to use the cloud. And again, this is something that we see a lot in big companies. So we actually did the whole POC on a laptop. So their IT department basically just gave us a laptop. We installed Solvexia on it, did the whole POC on that laptop, which was interesting. So that was the POC, and like I said, it went really well. Everyone was ready to go and really take the whole thing live. So expanded out to the other regions and so on. But then we had what should be, I guess, a partially predictable obstacle, which even though we'd done the POC, the IT department was still dipping a toe in the water in terms of cloud. So they weren't ready to move on to the cloud, but they needed a solution really, really quickly. So the challenge they were facing was that cloud approval was around 6 months away. The in-house option, so the other option was to just set it up on some servers internally. That would still take over 3 months to set up and cost a lot more, obviously, with all the internal costs. But they really needed a solution as soon as possible. And there was really two things going for us. One was that the problem that we were trying to solve was super important. So it had people's attention sort of right across the board, both on the business side and in IT. And the other was the general level of pragmatism, both obviously on our side, but in the business side as well. So the idea was, well, if we've done the pilot on a laptop, why don't we just go live on the laptop until we get approval? So the first problem was the laptop was really, really slow, and nobody really wanted to work on that. So instead what we did was we actually went and we bought a couple of these machines. So these are gaming machines from a company called Alienware, and we installed Solvexia on those. So their IT department got them sort of company ready. We set up Solvexia on these, and we actually packaged them up and sent them there. And it's unbelievable. If you can imagine a big corporate office and one of these things sitting on the desk, and they're about this tall. And so they got a lot of attention, but it was great. So these things were super, super fast. In fact, they were faster than our servers. But we set up the remainder of the production process on these. We effectively went to the point where we were ready to go live with these machines. So the journey was, we did the POC for one region on the laptop. We moved to these gaming PCs to really take it live, and then when they were ready, we ported the whole thing over to the cloud. And in terms of the main outcomes, and again, it's the sort of things you'd expect. So 2 to 4 days of time saving. So that means the onshore people were getting the results 2 to 4 days earlier. The process was ultimately reshored as well, because really it's down to clicking a button to produce the results. And the checks are much more granular because they're all happening at the transactional level. And really the main lessons we learn from it is, and this is one that's been reiterated over time, is the importance of picking the right POC. The benefit of having a process that people beyond just the process owner really cares about. Persistence and pragmatism. I mean, the pragmatism was unbelievable. Being a Big Four bank and sort of seeing how some of these big companies operate, I was blown away by sort of across the board how hard people tried to get it pushed across the line. The willingness to run Solvexia on a gaming PC was pretty amazing. And then the other piece was the need around data assembly, as I talked about, so stacking the data, etc. And when I talk about my next case study, that goes into that in a little bit more detail as well.